Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan nama saya Revin Pasya dengan NIM 11.011.90413. Di sini akan menyelesaikan project setting up microwave antenna. Jadi pertama-tama adalah microwave antenna. A microwave antenna is also a group printed antenna. Is an antenna that is produced on a printed circuit board using photolithographic process PCB. It functions as an internal antenna. Microwave frequencies are mostly commonly used. RFD, mobile communication, and healthcare are all industries that use microwave antenna. An RFID system is made of two parts, a tag and a reader. It typically operates at frequencies ranging from 30 Hz to 50.8 GHz. Microstrip antenna operate at 2.45 GHz in telemedicine applications. A microstrip antenna consists of conducting patch on a ground plane separated by dielectric substrate. This concept was developed until the revolution in electronic circuit miniaturization and large-scale integration in 1970. Many authors have described the radiation from the ground plane by a dielectric substrate for a different configuration. The patch antenna consists of a metallic conductor, white arbitrary shape radiating element, and deposited on a dielectric substrate. The lower face is completely metallized to provide a ground plate. So this is the feed which connects the patch here above the substrates and the ground plane. Structure of an microwave antenna in its most basic form is made of a radiating patch on one side of a dielectric substrate and a ground plane on the other. Rectangular and circular shapes are the most prevalent. Other shapes are also employed, such as square, meandered, triangular, semicircular, and annular ring shapes. The patch is usually made of conducting radiating materials such as gold and copper. This is the basic form of the microwave antenna. If you can see in this right image, patch antenna, which is this one, is a low-profile antenna that can be installed on a flat surface, which is on top of the substrate. A rectangular, circular, triangle, or any geometrical sheet or patch of metal is installed over a large sheet of metal called a ground plane, which is this. For this project, we'll be using a single rectangular patch. As you can see, the patch will be rectangular. A substrate is a dielectric constant, and the loss tangent of the substrate have a significant impact on the antenna parameters. A comprehensive analysis of the effect of various substrate material on an antenna characteristic is presented in this research. The software HFSS is used to access the fork type antenna for various substrate. This project will be using a substrate RT6006, frequency of 14.3 GHz, polarization of linear, gain of 3 dBi, and feeding method will be a microstrip feed. Formula, we use a patch length, which is delta L equals to 4.112 with the coefficient plus 0.3 WPH plus 0.26 divided by coefficient 0.258 divided by times WFA plus 0.8, in which the patch width will be equals to C divided by 2F square root of 2 divided by CR plus 1. The feed length will be lambda equal to CF G1 1 divided by 90, which times by WP divided by the lambda. Ground plane will be WG equals to 6H plus WP, LG equal to 6H plus LP. And finally, the VSWR will be using this formula is equal to Vmax divided by Vmin, which equals to 1 plus R times Z divided by 1 minus R divided by Z, RZ, yes, RZ. So after the calculation is done, this will be our simulation. From the results, it can be considered that a single rectangular patch width has been successfully designed at a frequency in 4.3 GHz in linear polarization and a gain of 3 dBi using RT6000 as substrate. You can see this as parameter, the value of dB is decreasing over the frequency. The frequency is increasing, sorry, but the dB will be decreasing from 1.5 from 1.5 to 5.5, frequency will be increasing to 16 gigahertz. The time signal, it shows that in the interval between 0.8 and 1, there's a massive increase in W, 1.5. And the VSWR is also decreasing from 11 to the number, but it's increasing in frequency gigahertz to number 16. This is our final patch, the final drawing of our simulation. This is the far field gain ABS with the pi is equal to 180 and pi in the left side is 0. Thank you for listening to my presentation. I will see you next time. Assalamualaikum warahmatullahi wabarakatuh.